Hi class, welcome back. So today we're gonna go over the lesson for the data science finance data project. So this is just to go over some possible examples that we can analyze data and visualize it using, in this case, finance. And just to full disclosure, this is not a finance class, and this is not a way for you to use it to predict any stocks. So please don't take it as an advice. It's just for us to play around with it and analyze the data. Okay. So as you can see right now, I'm making the video, so you won't be able to see the video right here. But what you need to do first is you need to click on the link so that you can download it to your computer, and then you're gonna open it up on Colab. So you're gonna click open, select your. You're gonna go to upload notebook. So you're gonna select the file that you just downloaded, and you're gonna open it up here, and then you're gonna be able to see the whole thing. All right, so we're gonna start with this, and so this is the lesson for the data science project. So this is just a lesson you're gonna do. You guys gonna do a lab and a final project on this on your own. So in this data project, we will focus on exploratory data analysis of stock prices. Keep in mind, this project is just meant to practice your visualization and Panda skills. It's not meant to be a robust financial analysis or be taken as financial advice, okay? Note that this project is extremely challenging because it will introduce a lot of new concepts and have you looking things up on your own. Will point you in the right direction to try to solve this task issue. Feel free to go through the solution selection notebooks and videos as walking through project if you don't want to have to look through this up. So this will learn, still learn a lot from this way. We'll focus on the bank stocks and see how they progress through the financial crisis as the way to early 2016. Okay, so this is gonna be going back to 2016 and 2008. So 2016, 2006 data analysis. So if you want to check that out, you can check on this financial crisis if you want to. When I get the data, in this section we'll learn how to use Pandas to directly read the data from the Google Finance. In this case, we're actually gonna use, it's gonna be Yahoo. In this case, Google doesn't allow you to do it anymore. So where is the, right here. Right. And so first we need to start with the proper imports. We'll have already laid out you here. You will see the install Pandas data reader for this work. We'll need that. The Pandas data reader allows you to read stock information directly from the internet. We're gonna use this link for install guidances. So we're gonna install some of that information. All right, so the first thing that we're gonna do is we're gonna install from the Pandas data reader, and we're gonna import data. Actually, that could be one way of doing it, but it's not gonna work anymore because that was the old way of doing it with Google. So instead of actually using that, we're gonna actually use get data. We're gonna import Y finance as Y. Okay, so the reader doesn't quite work anymore, but we're gonna use this finance way of doing it. I'm just gonna use. I forgot that is not allowed anymore. All right, so note that you could have done it like that. I'm gonna write them here, but we're not gonna use them. So I'm gonna put it there. We're still gonna import pandas as PD. We're gonna import numpy as MP. We're gonna import data time. We're gonna import Y finance as YF, and we're gonna do yf.pdr override. Let's see if this is okay. Finance. I think so. Why is it highlighted? Let's see. Date time. I was misspelled date. All right, so that worked. Okay, so what we're gonna do now is we need to get data using the Pandas Y finance, and we will get the stock information from the following banks: Bank of America, Citigroup, Goldman Sachs, JP Morgan, Morgan Stanley, and Wells Fargo. We're gonna figure out how to get the stock data from January 1st, 2006 to January 1st, 2016 for each of these banks. We're going to set each bank to a separate data frame with the variable name for the bank being its ticker symbol. This will involve a few steps. So we're going to use data time to set the start and end time of the objects, figure out the ticker symbol for each bank, figure out the data Y finance to grab it into the stocks. And this is Yahoo Finance. All right. As you can see, the warning was here that that I remember putting it when I was setting up this, is that sometimes the working API for Google may not always work. So that's why we're trying to do something different, which is the Yahoo. Um, so that we can use the Y finance. All right. So let's start with this. So what we're gonna do right now is we're gonna set some start dates. So remember we said we want to start it January 1st, 2006. So what we're gonna do is we're gonna set a object of type date time, and we're gonna use one of the methods date time to set up an object that contains that date time. So date time is the package. Date time is the constructor. So in this case, we're gonna use 2006, and we're gonna put January 1st. We can do more if we want to do the hours and integers, but we're gonna keep it just an hour day. We're gonna have an end date. And again, the date time is coming from the package, and then date time is the constructor. So we're gonna use 2016, comma 1, 1, comma 1, comma 1. So that's January 1st. So we're gonna do a start and end. Now what we're gonna do, we want to make sure that this is running. Right, so now the next thing we want to do is we want to be able to extract this data from the Yahoo website. So what we're going to do is let's label our first one. We're going to call it back. So that's one of our Bank of America information. And we're going to do a data. So we're going to refer to the data. We're going to extract data and we're going to use this method called get data underscore Yahoo. So this is going to allow us to be able to extract data from this kind of like API. This is an API from the Yahoo website. And what we're going to do here is we're going to look for the Bank of America with a start date. So this is the object start, and then we're gonna turn it into a date, or we're gonna make it into a date, and that's the first that is the beginning of a period. And we're gonna end, that's gonna be the object, and we're gonna refer to in the form of a date. So we're gonna use the date parentheses, and so as you can see here, this is a method of date time that it's so the object, remember, is end, and the method in this case is date. So we're returning the date of this object. Oh, we did need to use the data reader. Sorry. So we do need this data reader from this Pandas data reader. Sorry about that. So we do need that Pandas underscore data reader import data, but we're not going to use the web. So yeah, so that's why. That's why I was complaining about the data. And I need to run this again. And it's WB. Okay, so we still need to make that correction, and then we're gonna go down here and we're gonna run this with our date and our back. As you can see, it successfully extracted data. So we're using the data reader data to be able to call in this getter from the is a getter to the API of the Yahoo financial website, and we're gonna look for the Bank of America. So that's specifically the type of bank that we're looking for information. This is going to be the start date and the end date. So we're gonna repeat this for all the other ones as well. So we're gonna do the same thing for the Citibank. So we're gonna do this and this. We're gonna repeat this 6 times. It's always good to put the label for the label in which where a comment saying where is this coming from, right? Where is this initial for? Let's do here Citibank, Citigroup, sorry. And this is going to be C, and the title is C. It's going to be the same dates. The next one would be Goldman Sachs. And the Goldman Sachs will be GS. And here the label is GS. And then the next one would be JP Morgan. And we're gonna have JP, JPM, JPM. That's the label. And then we're gonna do Morgan Stanley. and this is going to be ms, and then we're going to change this to ms. So practically right now what we're doing is we're extracting the data from the API of the Yahoo financial website. It has a special tool that we can use, so that makes it easier. And this is going to be the Wells Fargo, I think. Wells Fargo, yeah. And we're going to call it WFC. And let's run this again, just to see if it's running. So as you can see, it's extracting the data from the website, successfully completed. All right. So the next thing that we want to do is, this is just, we can actually combine everything in one single thing, but we're gonna skip this one. We're gonna go straight to the tickers. So what we're gonna do here, we're gonna create a list of the ticker symbols that we're gonna use to be able to label our columns when we actually create our data frame. So remember, a data frame can contain multiple dimensions or multiple levels of columns and multiple levels of rows. So this is gonna allow us to be able to create multiple levels of columns. So we're gonna have the Bank of America, the city groups, the Goldman Sachs, the JP Morgan, the MS, which is the Morgan Stanley, and then the Wells Fargo. So right here, we're creating a list that we're gonna use it for our when we concatenate our data frames. So here we're gonna use the concatenation, the Pandas concatenation, to be able to concatenate different datas. Remember, a data frame is practically a combination of series that you can put together. And that's practically what we're gonna be doing. Is we already have this data, and what we're gonna do is we're gonna combine them into a single data frame. And the way we're gonna do it is we're gonna call it bank stocks. This is gonna be our bank stocks. And what we're gonna do is we're gonna use the PD concatenate, and we're gonna pass in our data, which is back CGS JPM MS and Wells Fargo. Now, so this is passing in the data. So this is gonna be our data that we want to put in, that we want to collect into our data frame. And so what we need to do is we need to indicate to the computer, right, to Python, how do we want to display this? What is this Bank of America, Citigroup, Goldman Sachs, JP Morgan? What is this data going to represent? So this is going to represent, we want to store it as a form of columns. So what we're going to do here is we're going to say, well, I want my data to be as columns. If I put 0, that means it's going to be as rows. So I want to specify that this information, this data, will be placed as columns. And then what we're going to do here is we're going to place some keys, which are going to be our tickers. So that's why we needed to create this list, to be able to pass that in as our keys. And then let's see if this is going to, oops. And there you go. So it didn't complain, so that's good. And so now what we can do here is we can set some columns. So right now, if I call in, if I go and do bank stocks and run it, as you can see, it's creating each information when we extract the data contain an open, high, low, close. Um, this is volume. Forgot what this one is. Let me see. So while the close column represents the closing cost at the end of the date, the adjust closing price, the edge close, is the adjusted closing price that takes the dividend, stock splits, and new stock offerings into the account. So the adjust closing price is a more accurate indicator of the stock value since it starts where the closing price finishes. Okay, so that is that definition. And so as you can see, every bank is gonna have this information, right? You can see that it's gonna have that information, and so on and so on. Now, notice on the left side, we don't have labels for the banks or the uh, for the open, high, low, close, adjusted close and volume. So what we can actually do is we can actually place them we can place a columns name. So this is what this is doing. This is setting up the close names for those for each level. So what we're gonna do is we're gonna call it the bank stocks. We're gonna refer to the columns and we're gonna assign them a names. So we're saying here, look at the bank stock data frame, go to the columns, and then to the names, and we're gonna assign them the bank ticker and the stock info. So if I run this, and now I can check my bank stocks, I can see that it now has a labels on the left side. So you can see the bank ticker and the stock info, and it's done in the same order that I placed them. So the bank ticker was first, so it's gonna be the top, the name of the Bank of America, city group, the what is it called? I always forget that one. The Morgan Stanley, the Wells Fargo, and so on and so on. So it has give them an information, right? And also the stock info. So here we now finally have our data frame. So sometimes that's part of the process, right? We need to be able to extract the data from whatever API file that we're given, and then be able to place that information, set up the information so that we in a form of a data frame, so that we can actually be able to play around with it by using data visualization or data analysis with different tools like regression, the mean, the standard deviation, and so on, right? So that is a good process. This is an important process in data science, right? We extracted the data. If we actually do dot info, it can tell us a lot about the information that we have. This is saying that it has 2,517 entries. That means columns. Rows. This is going from 2006, 2006, January the 3rd to 2015, 12 to the 31st, right? And it has 36 columns. And you can see that every single column has a non-null value, which is good, right? We want to make sure that our data is clean, right? What does that mean, clean? Every single row and column has an entry. Also, there is no skew data, like not null, like null data, so that would be bad. So we need to fix that to be able to analyze the data and visualize it. So this is a clean data. We don't have to do anything else to it. Notice that it's there. You can see it. I can always close it if I want to. So now what we're gonna do is we're gonna explore the data a bit. We're gonna before we continue, we're gonna encourage that you look at the documentation for multi-level indexing and using AX reference the solutions if you cannot figure out how to use it .x since it's a major part of the project, right? So what we're gonna do here is we're gonna we're going to calculate what is the max close price for each bank stock throughout the time period. Okay, so we're going to look at the time period. Now, I didn't do something here. I could have done also, I could also do the head. The head is also a good way to see how our data looks like. And you can see our data looks like that, right? So the head is the first 5, and then the tail will be the last ones. It's probably why, even though we put 2006 January 1st, but it started in January 3rd, it's probably because, remember, during the weekend, the stock market is closed, so it's probably, it was closed on the, maybe January 2006 January 1st was Saturday, and Sunday was January 2nd. So there's no data there. Now what we're gonna do here is we're gonna show how we can actually extract, how we can figure out the maximum value of our data, and so what was the maximum value in closing? Like, what was the closing price in the period that we have right now, January 1st, 2006 to January 1st, 2016. So we're gonna figure out what is the maximum closing price. So we're gonna do a XX, XS, and we're gonna put the key value, which is gonna be our closing. We're looking for the close column. Again, because the column we need to specify that is going to be index 1, sorry, axis 1. The level, right? There's different levels. If we go to the ticker, that's going to be the bank. But if we go to the stock info, right? Because we're looking at the close, that should be the level with the stock info. And we're looking for the maximum value. Now, here, close is supposed to be capital. As you can see, it is capital here. So I have to match it the name of the column. So if I run this, we're going to be able to see that the maximum price for each one was 54 in that period, 564 for the city group. The Goldman Sachs was 247, JP Morgan 70, Stanley, whatever, Morgan Stanley, I think that's what the name is, it's 89, and then the Wells Fargo 58. So we can see what the maximum value was in that period. There's also something that we can actually return. Like we can figure out what is the return of each stock. So what we're gonna do is we're gonna create a new data frame called returns. This data frame will contain the returns for each bank stock. Returns are typically defined by, so here's the formula. So this is the return of every stock, formula for a stock. So what we're gonna do here is we're gonna create an empty data frame. So we're gonna say returns equals PD Pandas data frame, and then we're gonna do it 2 different ways. We can either use a for loop, so we can use a for, and now remember that the tickers are the ones that are going through every single bank. So we're going to go through every single bank. So the tickers has the name of the banks. It's a list of the names of the banks. And what we're going to do is we're going to create this return. And remember, if we want to assign a column, if we want to create a new column in a data frame, all we have to do is generate a different name. So we're going to do here, we're going to generate a name by doing stick or tick plus the name returned. So what we're going to do is we're going to create this column that is going to be the name of the bank and the word return. And we're going to assign a value there. We're going to assign the value of the bank stocks. We're going to look at the tick, which is the name of the bank, and we're gonna look at the close value of that bank. And what we're gonna do is we're gonna calculate the return, which is this formula pt minus 1 divided by bt minus 1. So we can just use the formula pt underscore change. And then we're going to returns head. Let's see what we get. So this is going to go and calculate every single point change. So it's kind of like changing, it's calculating the rate of change sort of between every single stock. So so that's going to calculate it for every single date. So you can see here the data frame, right? In the first one, you don't have any rate of change because you don't have a previous information, but then you can have this change from the one from before, right? So you can see here that this is a negative value because it probably went down. So when you have a negative value, it means that it's going down, and a positive value means that the value is going up. So this is just showing the first 5 values. Now, what we can do here is also we can visualize the data by using the Seaborn. So we can do import Seaborn as SNS, and then we're going to do SNS. We're going to call this function pair plot that is going to use the returns value from 1 all the way to 0. The reason we want to start at 1, no 0. The reason we want to start at 1 is because you notice that in 2006 January 3rd, there's no data, so we can't graph a null value, right? So that's why we're going to extract that information. And now we do this, so this is going to create a pair plot. What does that mean? It means that it's going to compare every column with each other. And so to be able to compare if there is any correlation between each of them. Sorry, I think I put a period, a star there instead of parentheses. Sorry about that. Seaborn has no attribute pair plot. I think I'm spelling it wrong. Pair plot. All right. What else? Pair plot. Oops. Sorry, I'm gonna have to run the other one first. That's why. So it's because I didn't run the one before. All right, so we can see the comparison, right? So here we're comparing the back with the back, so that's why you get this graph. But if you compare the back, or let me put it down here, you can see visualize it better. If we compare the Wells Fargo return with the Bank of America return, you can see that there's a linear correlation, right? This is a very beautiful line, straight line correlation between them. So you can see that there's a correlation between the Wells Fargo return and the Bank of America return. You can see that the Wells Fargo return and the Goldman Sachs return is not very linear. It's a little more spread. The Morgan Stanley return and the Goldman Sachs return has a much more straightforward, which is nice. You can see here that the JP Morgan return and the Goldman Sachs return is not very linear. And also here the Goldman Sachs return and the Wells Fargo doesn't have a very straight linear regression. So you can see the correlation, so you can determine which ones you're going to be analyzing, which data you're going to be able to use to analyze your data. So in this case, we're going to look at the Am I missing something? Create a paraplot using the seaborn of the returns data. What stock stands out to you? What can you figure out why? So yeah, we talked about that. So we also see that there's enormous crash in value if you take a look at the stock price plot, which we're gonna be able to see later on too. So if we look at the data in the dates, they're gonna be able to see there's a crash in the data in the information. So right now what we're gonna do here is we're gonna use this return data frame to figure out what dates each bank stock has the best and worst single day returns. So you should notice that the four of the banks share the same day for the worst drop. Did anything significant happen that day? So how can we figure out the uh, the when the bank crashes, when they have the smallest value? And we can see here what happened here. Oops, I missed an X there. Returns the IDX minimum. Sorry about that. All right, so let's see here what we can analyze. So this is gonna return the minimum value date, price, and what date did this happen. So we can see here the Bank of America returns has the lowest value at 2009, the Citigroup at 2009, the Goldman Sachs return 2009 on the January, JP Morgan 2009 January, Morgan Stanley return 2008, and the Wells Fargo return 2001. It seems like a lot of them, four of them at least, have the same value or the same minimum value in 2009 January 20, and that's probably why, because we have the crash when we have when the banks crash and then they needed to build bailout, right? Yeah, it's interesting that it is that they want that people claim that we live in a social in a free market, and they expect that the big companies get bailed out. So and they can make all the they can make all the sacrifices, or when you they can make all these dangerous investments, and when they do well they make money, but when they do bad they're expecting the government to bail them out, right? So anyway, so where does this continue? Sorry, my computer, I'm not sure if it's working or not, my recording. Seems like it's working, but when I press the button it doesn't pause. Anyway, so hopefully it's still recording. All right, so now let's see. You should have noticed that Citigroup's largest drop and biggest gain were very close to one another. Did anything significant happen in that time frame? Yes, right. We had uh, that's where am I? Let me see. All right, so the best single day gain. Let's figure out that. So that will be returns dot. We're gonna do the IDX max instead of minimum. We're gonna do max, and this is gonna show us the best day that they ever had. So you can see here that the best day for the Bank of America was 2009 on April, and then Citigroup, Goldman Sachs 2008. So just right before they actually, and then also the Morgan Stanley and the Wells Fargo, just before they actually had a crash, they were making the most profit. So they don't have to pay that money back, right? So they can make all the profit, but when they fail, they're expecting to be bailed out. So yeah, that's really fair for everybody. It's like if I invest in the stock market and every time I make money, then that's good for me. But if I make a bad, then I'm expecting somebody else to bail me out, to give me the money back that I lost. Yep, very fair. So now let's take a look at the standard deviation of the return. Which stock would you classify as the riskiest over the entire period? Which would you classify the riskiest for the year 2015? So we're gonna do returns dot standard deviation, and let's see what we get. So when we standard deviation means the one that has the most possible change. So here, the greater the value means that there's more likely that the value of that stock will go higher up or lower down. So that means that it's the most riskiest. So in this case, we can see that the one with the most risk is Citigroup, because it had the higher standard deviation. And so if we want to specifically look at 2015, what we can do here is we can do returns dot log. Now remember that log, it's a way to be able to emphasize which index type, which index values do we want to be able to look at our rows. Now when we use log, we're actually looking at the location of the data. So we're gonna say 2015 01. So what this means is I'm actually given the actual index value, and I'm gonna make it all the way to, so this is gonna be a slicing. I'm gonna go all the way to 2015, 12, 13. Sorry, 31. And so that's the, and we're gonna look for the standard deviation. So this is specifically just for 2015. The one before was for the whole period. So according to this, the most risky in 2015 was the Bank of America and the Morgan Stanley bank. So now here they want us to create a display plot using the seaborn of 2015 return of Morgan Stanley. So what we're gonna do here is we're gonna use the SNS, which is the seaborn. We already imported that, so we just can use the NSS. We're gonna use this distribution plot, and what we're gonna do is we're gonna pass in the data that we just grabbed, right? So we're gonna do, I want to look at this data right here, the standard deviation. So I'm gonna look at this. Not the standard deviation. I don't think we want to do the standard deviation. Yeah, not the standard deviation, just the data. I'm gonna put that as my data, and then I'm gonna look at the MS return. We're gonna choose a color for our graph. We're gonna use green, and then the number of bars that we want to be able to see. So let's do 100. So let's see. So we can see here that our the graph values are changing, right? And So this is a displacement plot of the graph, and you can see the standard deviation being shifted, right? Let's do the same thing for the city group. So I'm gonna copy this and change it to the city group for 2008. So let's change it to 2008, 2008. And we're gonna use the C return, and let's use red, and let's use 100 pins. All right, so we can see here our standard deviation plot, and where where's the majority of the values concentrate. So remember, this is going to place the values between -1 and 1. And then more data visualization. So here, I kind of gave it to you guys here. So we're using the matplotlib pyplot plt, and again, we already have the seaborn, so we don't have to download that. So we're gonna use the set style for our grid, which is gonna be the wider grid, and we're gonna install some plotty. We're not gonna go that far to do this, but as you can see, we want to be able to graph this part right here. So we want to be able to graph this graph. So what we're gonna do, we can do it 2 different ways. We can use the for loop, where we take the tick. Remember, the tick contains the name in tickers. Remember, contains the name of the list of the columns for each bank, and we're gonna use bank stocks tick, and we're gonna use at the close data when they close, and we're gonna use plot to plot the graph, and we're gonna choose the size of the figure. It's going to be 12 by 4, and then label equals. We're gonna plot the legends as well. And let's see if that works. I forgot to run this right here. All right, and then let's run this. Cannot put single artist in more than one figure. What did I miss in here? Oh, it's fake size. Fake size. There you go. And you can see that we can visualize the stock price for each of these banks. You can see that in 2008, we have the city group falling down, the Goldman Sachs falling down. The other ones were they're too narrow to be able to see them, but they're also falling down. We can do the same thing, but using the XS. So we can just use the bank. So this is like if you want to run through every single label of your columns, you can use the XS, and we're gonna use the key equal to close. We're gonna be looking specifically at the close, and we're gonna look at the x-axis, which is the column 1. The level, right? Remember, the level is the stock info, and we're gonna do a plot, and we're gonna do the fixed size equal to 12, 4. All right, so let's do. As you can see, it does the same thing. It does the same graph that we did before, but this doesn't need to require to do the for loop. And we want to try to avoid using as much for loop as possible. So this is a better way of doing it. So by using the XS method allows us to be able to iterate through different column columns in our data frame. So how do we know? Well, we're going through the level. We're going through this column name, which is the stock info, which is the and we're gonna go through every single key column name flows. And then let's do one more. Let's do the moving average. So let's say we want to figure out the moving average of our stock for just one of them. So let's analyze just the moving averages for this stock in 2008. We're gonna plot the rolling 30 days average against the close price for Bank of America stock for 2008. So what we're gonna do is we're gonna create a first object figure, and let's give them a size 12 and 6, and back of America will be, we're gonna be looking at the close values, and we're gonna, since we're using the actual named value in the index, we're gonna use the log. If we want to use the number, the index location number, then we can use ilog. Remember that. In this case, we're just gonna use the actual value on the index, which is 2008, comma, no, sorry, -1, and we're gonna go all the way to 2008. That well, let's do 9, and we're gonna do 1, 1, and we're gonna do the rolling. So the rolling is going to do is gonna average. It's gonna allow us to be able to average well, it's gonna allow us to be able to figure out the a 30-day period of an average. So we're saying that we're gonna roll 30 days, or not 30 days, but in this case they're days, right? Of data, and we're gonna calculate the mean of it, and we're gonna place that in our plot. So for each one, we're gonna calculate 30 days for each day, and then we're gonna do the label. We're gonna label it as 30-day average. And the next one looks very similar, but we're gonna do the back. So that's for the blue line. Let's say I want to do the green line. So the green line doesn't require anything else other than just plot the values that we have. So we're gonna just call the label equal to the back close. And we're gonna make sure that